Now I'd like to take a few minutes to introduce you to a special kind of method. It's called the constructor. Constructors are declared a little bit differently than normal methods because they have the same name as the class. Constructors are typically used to initialize or preset any data that needs to be created in a class. And we can also use it to make sure that when somebody else creates one of our classes, that they have to provide valid data before they can instantiate it. And I'm going to demonstrate that right now. I'm going to add a class, and I'm going to call it rectangle. And this rectangle class is going to represent the shape of a rectangle. Now, one thing you don't realize as a beginner is that every class that you create automatically gets a constructor. This is why in program main, I can declare a rectangle, instantiate it, and the new keyword is what calls the constructor. And by default, that constructor is going to be blank. It's not going to do anything. So if I put in a console.readline to stop the app from closing, and just run this code, of course nothing's going to happen. It's just going to sit there because we didn't actually write any code. However, this constructor got called, and if you want to see the constructor, all you have to do is use the name of the method and make it public. You can also make constructors private and static. Those are advanced scenarios. I'm only going to show you the simplest scenario, the public constructor. Like any other method, it has to have parentheses. However, you'll notice that there is no return type for a constructor, and that's because the return type is an object of the class rectangle, so it's not necessary for us to specify that. In this constructor, I'm going to write line, we are in the rectangles constructor. Just like that. And now if we run our app again, you will see that it printed out, we are in the rectangles constructor. This constructor gets called when we instantiate the object. That is when the constructor runs. So what can we do with things like this? Well, we can have multiple constructors. This is called overloading. And one of the things about a rectangle is that it's not valid unless we have a length and a width. So let's add two properties, a length and a width, just like that. And let's take in two parameters into our constructors. And we'll call this one side A and this one side B. And inside the constructor, we are going to set the local variables length to side A and the width to side B. And then we could create a method called getArea. That's going to return an integer, and it's going to return the length times the width. And in the default constructor, I'm going to set the length and width to 0. Just like that. So now we have two constructors. We have an empty constructor that will set the length and width to 0, and we have a constructor that takes in two parameters, side A and side B, and sets the length and width to those. We also have a method that calculates the area by returning the value of length times width. And let's put in a console write line here. This is the constructor that takes two values. Okay. Now, in our program, we've got this rectangle, and let's write out its area. Just like that. Then let's create a second rectangle, and this time we're going to use the constructor that takes a length and a width. And we'll pass in 5 and 10. And then we're going to print out the second rectangle's area. Just like that. Let's put a breakpoint in and run this program. Let me shrink this down for you. There we go. Now we've paused before we hit the constructor. If I step into this new statement, you'll see that it enters into the empty constructor. And that is because we did not pass any parameters into the new rectangle. So by default, it's going to call that empty constructor. We keep going. It's going to print out that we're in the rectangle's constructor. It's going to set length and width to 0. Comes back out to main. It's going to write out the area, and it's going to put the result of the method getArea into our substitution string. So as soon as we call that, it returns length times width, which is 0. And that's going to print out to the console. Then we're going to create a second rectangle. And this time, we're passing 2 integer parameters in. C# looks at the types that you're passing in, and it says, oh, here's a constructor that takes 2 integers. I'm going to pass it to that. 5 goes into side A, 10 goes into side B. We're going to print out that this is the constructor. We're going to set the length and width. And then we're going to print out the area, which should be 50. And it didn't. Why didn't it do that? Well, because I made a little mistake here. I had rectangle R and rectangle R2, and I printed out r.getArea. So it ended up printing the area of R twice, which was 0. So these things are easy to happen if you don't make your names very unique. So that's bad on me. I'm going to set this one to R2. I'm going to rerun the application. And now you see we get the proper result. Area 0, area 50. And I'm going to leave this in the video because it's good to see that experts make mistakes too. Returning to our application, we can see that the use of constructors can allow us to pre-initialize the data of a class. But there's one thing that's really interesting that we can do with constructors. I mentioned that by default, we always get an empty constructor, because we always need to be able to create an object from our classes. However, if you specify a constructor with parameters, and you don't put the empty constructor in, that means that you are not allowed to use the empty constructor anymore. So in this way, you can use a constructor to force another programmer to provide you data to your class when they instantiate it. I deleted the default constructor here, and now when I go back to program main, you see we've got a red squiggly here, and it says error. Constructor demo.rectangle, that's the namespace and class, does not contain a constructor that takes 0 arguments. Arguments and parameters are interchangeable. They mean the same thing. And it's basically saying, well, I looked at the rectangle class, and I see a constructor that takes 2 arguments, but I don't see one that takes 0. So just keep in mind when you're working with these constructors that if you provide any constructor that has arguments and you want it to allow an empty constructor, you have to explicitly put it in. However, If you don't have any constructors that take parameters, C# will automatically generate the empty one for you. And the only reason you have to specify it is if you want to do custom logic inside the constructor. The last thing I want to show you is method overloading. I already demonstrated that we could have multiple constructors for the same class. The only rule is that each constructor must take different types of parameters. I cannot have a constructor that takes an int and then add another constructor that takes an int. The types have to be unique. This also works with methods, as I'm going to demonstrate here. I have a class called calculator. I'm going to add a couple methods with the same name called add. So let's say public int add int a int b. And we're going to return a plus b from this method. Next, I'm going to add another int add, and this time I'm going to take a, b, and c. And this is perfectly fine. We are allowed to have the same type and the same name as long as the methods have different parameters. This is called overloading. Sometimes in your journey as a programmer, you may come across a need for a method that may or may not have all of the parameters. In that case, you can use overloading so that the user can specify as many parameters as they need, and then you can provide default values for the others. This also works with different types. If we do it with decimals, this is also just fine. The only thing that's required for overloading is that the return type or the parameters have to be different types. The names of the variables don't mean anything at all to the C# compiler. It only looks at types. It sees decimal, add, decimal, decimal. Int, add, int, int. As long as those signatures are different, method overloading will work just fine. So let's walk back over to main. Let's spin up a new calculator real quick. And then we can print out some of our methods here. Let's put a substitution string in. And we will do c.add 1, 2. And we can also do the overloaded method with 3 parameters. 1, 2, 3. Put in a console read line so that doesn't close. And you can see, indeed, we were able to call both of those methods, and that was fine.